So, welcome to my talk about using PowerShell to make your automations more sustainable. Welcome to the people who are just walking in. You're also allowed to sit in front, like I said before, but feel free to sit wherever you want. I think the audio is quite good here. Let's first start with thanking our sponsors. If you haven't checked them out yet in the foyer, do. Especially I would recommend Jane Street. They have this fidget toy. It's so addicting. I had to put it on my hotel room because else I would have probably been playing with it now already. It's this keyboard thingy, and you can just it's the clicky switches. It's awesome. Okay, so thanks to all the sponsors. Check them out if you haven't done it already. And let's continue with the talk. So, I'm Leo Visser. I'm from the Netherlands. And I'm a cloud consultant. So I work with many different companies to get them to the cloud or use cloud technologies. But at the same time, I'm also the product owner for automation and AI. I promise that I will try to mention AI not at all in this talk. It might appear here or there, but then it's mostly to bash on it. So I hope you like that. If you're here for a talk about AI, sorry. I'm also a Microsoft MVP and an MCT. And you can find my blog on autosysops.com. I'll hope to be able to post some more posts soon again, also about the things I'm now going to present. So if you're interested in more about this, keep an eye out on the blog or on the socials. You can find me on the socials or on LinkedIn. I hope the stage will survive. So, what are we going to talk about today? We're going to talk about sustainability, but first we're going to talk a little bit about why sustainability. Then we're going to talk a little bit about sustainable code. Then we're going to talk about some of the data which is available. I'm going to share some of the ideas I have. Will be quite demo heavy, this part. And I'm going to talk some things about future ideas I have. And one warning, I don't have complete solutions yet. I wish I would be here and say, the problem is solved, here's how you can do it. But I hope this session will inspire you to maybe think about some of these things in a different way and also look at some of the things I've been looking at and start using it, or at least thinking about how this maybe could be incorporated in your automations at all. I'm really afraid of this stage. So, sustainability. It's a word used in a lot of different ways. And many times, people think about sustainability mostly about carbon emissions, CO2e emissions, but it's a lot more. Sustainability has 17 different areas defined by the United Nations where we're working on to improve sustainability. In this talk, I will be mostly focusing on the environmental part, the part about the emissions. There's still a very long journey ahead of us to really go to a sustainable way of working, a sustainable way of doing business, especially if you look at stuff like the gender equality or the no poverty. These things won't be solved over one night of ice. I think that's also an English expression. And what we can mostly do as people working in the field is looking for opportunities, spotting the things where we can contribute a little bit. I don't think many of us will be in positions where we can make very drastic changes. If you are, I would love to talk to you afterwards. But we all can make small changes, and these small changes, they can create a snowball effect. So do keep looking for these ideas. So why do we want to think about sustainability? Because if we're working for a company, unless you're working for like a government company, probably the goal of your company is to make money. And most of the things in sustainability, they won't really be a way to make money. It's mostly a cost thing. So it's already hard to sell this to a company. IT is a significant factor in at least the emissions. And the climate is, I'd say, quite well impacted by emissions. I'm not here to make discussion about this. If you have other beliefs, that's your beliefs. But if you believe that the climate is impacted by these emissions, then IT is a significant factor in this. But it's hard to sell corporates to really do something about this. But there are some things on the horizon, or actually already past the horizon, but we haven't spotted them that much yet. One of them is the Corporate Sustainability Reporting Directive, a directive in the European Union, where most companies with 1,000 employees or more are required to start reporting about the emissions and so on they produce, both by themselves and by their suppliers. This has been coming for a long time already. It's actually already in effect, but many companies are not doing that much with it. It's done by some person in the company who they said, probably somebody from HR or somewhere, where it's like, you're going to make these reports, and they gather some things, use some tools, and it's done. Personally, I'm not sure if this will be a solution which which will keep working for them. And when the audits will become more and more strict, I think problems will arise and people will need to think more about this. Also, if this data and these values will be requested more often in tenders and so on, it might change things also. Another thing is carbon offsets, maybe something you've heard about, where companies buy ways to offset their carbon emissions. They're kind of a free market, the carbon offsets. So if the demand becomes higher, the price will go higher. So the amount of carbon offsets they can produce is limited and already very sketchy how some of them are produced. So I do see a situation where these carbon offsets will become more and more expensive. So companies might consider looking into other ways to not produce so much carbon emissions. So with that being said, let's look a little bit to sustainable code. Because if we're talking about sustainability and talking about ways to reduce our emissions, one of the ways we can do this is by fixing our code. I'm not going to go too deep in this. Jakub has done a very interesting talk about Profile already, a tool which can help you a lot. But there are some ways we can think about our code and maybe make it a bit better. Because most of the time, the amount of CPU cycles your code needs to run is directly correlated to the amount of energy being used, if none of the other variables change. So if you're running it on the same platform or whatsoever, reducing the amount of CPU cycles will reduce the amount of energy spent. So you're probably all already now starting to fall asleep a bit. A lot of corporate jargon, no code yet. So let's look at a little bit of code to wake up again. And let's make it a bit more interactive. People in the back, can you read the code if it's zoomed in like this? Good. I've got a piece of code here. And Well, actually, I asked GitHub Copilot to write it. AI mention 1, sorry. And I asked it specifically to write me some bad code. I don't think you can see the prompt anywhere, but is somebody able to spot a way we could improve this code? And there's probably many ways, so are there ways we could improve this code? The idea is that we're looking for some kind of number in an array. So this array now is just a series of number from 0 to 100, but it could also be a random array, and we're looking for this specific number in the array. Sorry? I don't need the loop? Sorry? Yeah, I could use one of the native functions in PowerShell to just search for it. Yep, or I could use a for each indeed. Although I'm not sure if for each num in or num for each. I think the second one is a bit faster, but yeah. There is another way we could actually fix this one. Somebody else sees an improvement? Yeah. Yeah, that works already, but it would still continue with a for each. So, yeah. Yeah, that's the one I was mostly looking for, that if we're running this loop, I can actually use my laser pointer. If we found it, we don't have to continue the loop anymore. We can just kill the loop, so we can jump out of it, break, or write it, and if it's some kind of function, make sure that the function is stopped. And this is something which happens in a lot of code. Here's a very simple example, but I've seen many scripts written by people, I wouldn't say lazy, but probably in a hurry. And these scripts, they run periodically, checking all kinds of mailboxes, checking AD objects or whatsoever. And there's loops just running and running and running. So one of the things you can do is checking these scripts and see if you can break these loops when you're done with going through the loop. That way you save a lot of CPU cycles. It will speed up your script and at the same time make it easier. So another one. I've added some comment here where I say, imagine this to be a CPU intensive operation. So we just have write output here, but maybe it's some kind of database query or whatsoever. Is there a way we could improve this one? Yeah. So you just mean the invoke my action, call it once. And why can we do this? Because we have this data set and we want to send the different ones there. Yeah, indeed, here I'm only using it once, but maybe I do need a function because I'm using it multiple times. But it is a solution. If this is everything you have, don't make it a function. I already kind of give it away with the naming of things. One of the things we can do if we do have lots of data or whatsoever is see if we can batch things together. If we have to do some kind of intensive operation, and this operation has the possibility to send multiple arguments at once, multiple queries at once or whatsoever, first collect them all together before you send them there. If you're working with Active Directory, with mailboxes or whatsoever, this is often a way you can kind of improve this code a little bit. This one was a bit harder. The code first looked better, and then I changed it, and now I see that it's not clear anymore. But the idea, what I mostly wanted to say here, is that if we're using some kind of API, often APIs have the option to request a bigger data set first, and then you can filter through it yourself instead of calling the API every time. There's things to be said about having everything in memory on your system. I think today or tomorrow there's also a talk about the problems with having too much data in your automation and just running out of memory. But calling an API will require multiple different resources to work. You have to go over the network, use some network resources. A different server has to pick up this request, manage it, then eventually send the request back. More network resources gets back to you. So there's a lot of steps being involved there. So if you can limit these API calls and request the data and then process it yourself, this might help with reducing the amount of energy spent. And please don't be that company who's like, so if we just send it all to this other company and we only get the data back and don't do any processing ourselves, our CPU cycles are less and it's their problem. This is why with the incentive and with the directive, you also need to report on the things your suppliers use. Because then it's just a matter of moving it from one box to a different box. But you're still generating it. Okay. So, if we want to improve our code, we can check the loops, use some batching, be careful with the API calls. Also, implement caching options. Either in our code or in the systems we use, add some kind of caching to reduce the amount of CPU cycles, reduce the amount of requests being done to the service itself. A cache, when put in between, should normally be able to do it in less work than the server itself. A different thing to consider is what are you running it on? If you're running code just locally, you probably don't have that much control about if the server is on or off. You do have all the control, of course. You can just press the button. And if you want to run an automation, first go into the server room, press the button, or use some kind of different automation. But most of the times, we kind of want our servers to be on if we're running it in our own data centers. If we're running it in the cloud, and we're using some kind of always-on infrastructure, like Azure Functions with an always-on setting, or virtual machines or whatsoever, they will be very quickly available and will execute the tasks quickly for us. But they do also consume resources when idling. I've been in situations where there was a big service provider for many different companies, and they were using PowerShell to do a lot of automations for their different customers. But because they had to interact with the different customers in every Azure environment for every customer, they made a VM which was used for these automations. So for every customer, there was a VM running. Some of these customers only had scripts run once or twice a day. The rest of the time, these VMs were just sucking up resources. So one of the things we did here was replacing these VMs with containers which were spun up the moment a request was being sent, do the task, and then spin down again. And they were running on a shared infrastructure from Azure container instances. So we didn't have to manage a Kubernetes platform or whatsoever. And this way, we not only reduced the amount of CPU cycles being used, but also reduced the amount of costs by a factor of, I think, 25 or so for these automations. And they couldn't really... it was pure gain for them, because the customers were just paying for the service they were providing and not for the amount of automations being run. So by reducing their cost for the automations being able to run, they will just make more money out of it. So everybody is happy. And that's one of the first things you always want to look at, especially when you're optimizing code, is see if you can spin it in a way where you can gain some money with it, or at least under the line be break even, and do make some improvements on the sustainability. If you can go to a customer and they have some kind of automation and they're kind of complaining that this automation sometimes is a bit sluggish or it takes a long time, and you can improve it by reducing the amount of CPU cycles, they're happy with it. They have better performance, maybe also lower cost because it might have to run less on the infrastructure, or it costs less if they use some kind of pay-as-you-go model. And at the same time, you improved the amount of CPU cycles. So you can also write this down as a win for you. You've also improved on this area. And don't forget to reward yourself for this, and to also tell the customer that they didn't only gain performance, but they also gained that they now produce less carbon emissions. Probably not that much. It all depends on how often this automation is running. So, that was a little bit about the sustainable code. Now let's dive into the more interesting part. The real meat of the talk. How can we make our automations more sustainable? So not only looking at a code, but looking at the whole thing. And before we do this, I want to look at some of the data which is available. I think the second one on here, many of you probably know, Electricity Maps. It's a site where you can ask for real-time energy information. The top one might be lesser known, the Carbon Data Initiative, and the other one might also be lesser known. So let's quickly look at them a little bit, and let's hope this stage will survive until the end of the talk. Not this one, sorry, this one. So the Carbon Database Initiative, it's an open initiative, and it's a place where people can report the carbon emissions. So you can, for free, make an account here. And once you create an account, you can look up, and you could look for example, look up Sweden. And you can see over the last year what kind of emissions they generated per kilowatt hours. So if you're making something where you're mostly interested in an average over a longer period of time, this is an interesting resource to use. They have the option to see the methodology used. You can see the things in the past, and you can also download the whole data set if you want to. There is also the option to look for companies. So these companies need to disclose themselves. But if they do, we could, for example, look up Microsoft. And we see that Microsoft, the US version, at one point at least did do some reporting here. Some companies do it more often here, some less. They're still working on getting more and more information here and getting it from different places. But this can help you to get an idea also for equivalent companies, how their emissions are. And it might be sometimes an interesting resource if you're talking with customers about actually improving their emissions, if you can show some comparisons with other companies. Do remember that at the moment this is self-reported. There's also options to check for products and materials and so on. So it's a very interesting resource. The other one was the electricity maps. Many of you might know this already. It's one of the more known ones. It has a free tier. And with the free tier, you can get real-time information about the electricity being produced in specific regions. But if you want to have forecasted data and this kind of things, you do have to go to paid tiers. It is an interesting platform. It has a lot of interesting features. People who use tools like Home Assistant and so on will probably have it being used maybe without them even knowing. Many tools for consumers which do some kind of reporting on the emissions use this in the background. Especially because it's available worldwide, so it tries to get the information from as many regions as possible. A personal favorite of mine is the Cloud Carbon Footprint tool. Some of you might have seen talks about Microsoft's sustainability dashboard. AWS and Google have their own versions of this. And they have a lot of interesting data in there. But personally, I don't trust a vendor to self-report that much on how well they're doing. I think Microsoft is doing quite a good job, and probably all the information in there is good. But I prefer also to have an open source alternative, especially if I want to compare different kind of cloud vendors with each other. The Cloud Carbon Footprint initiative is an open source initiative by people trying to create a dashboard you can easily set up in a container and connect to AWS, Google, and Azure. And they're working on some other system also, where you can get reporting in the same way. So you could actually compare your AWS environment versus your Azure environment. See what the differences are. In the docs, they have all the methodology explained. All of the methodology is backed up by different research papers. And they have very lively discussions on GitHub also about how some of the methodologies could be improved. People suggesting using different resources to improve the data even more. They work together with some students and universities to create data sets for specific CPUs and so on, so they can more accurately predict the amount of energy being spent by specific types of VMs and so on. So it's very interesting. Even if you're not interested in using the dashboard itself, but you are interested in sustainability by itself and sustainable IT, I can highly recommend checking out the docs, because it's a very good resource to start knowing more about how you can calculate these things. It's all very well explained in there, and all with links to more scientific resources. And then the last one is and I pronounce it ENSO, but if somebody knows how to actually pronounce it, please let me know. It's a transparency platform set up by the European Union, as far as I know. And this is the one we're going to use mostly for the rest of this session. It's a platform where you can see a lot of different information, and many countries and energy providers are required to report their forecast and generations and so on to this platform. So if you just go to the site, you will be welcomed by this site. They're working on a very nice upgrade. So soon it will look not like the arrow, but it will look like this, which looks a lot more fancy. And you can click, for example, a region. I like to click the Netherlands because I'm from the Netherlands. You can see how the load is at the moment, how the generation is, transmission, outages. There's different kinds of tables you can do. So, for example, I can do capacity by production type. And I can see that at the moment in the Netherlands, it's fossil gas being used, or fossil gas, solar, and so on. That platform is all very fancy. This is the platform I started with. You've got the same resources. You can go to generation. Let me quickly log in again. You can create an account for free. And you can go, for example, to generation, forecast a day ahead. And let's see if Sweden, yeah. And then tomorrow, it's not producing for tomorrow yet, but for today it is. So here it's showing the amount of energy Sweden is expecting to produce. And we're now somewhere around like 10:30. But they already have for the rest of the day. So this is based on earlier predictions and so on. This is also what they themselves use to predict which sites have to be spun up, which windmills have to be turned on, which windmills have to be turned off, and so on. They, for example, also have a generation where they say we just want to have the forecast for wind and solar energy. Now you can see this is a bit of an older site. There is something to the right, and you can scroll here also. It's not the most user-friendly. And yeah, it's showing that a lot of wind energy they expect to be produced. Oh, sorry. And for solar energy, not that much. We, for example, would look to the Netherlands. We also see wind energy, and you see that depending on the country you pick, you might get kind of different results. That for Sweden it was showing it for every hour, while for the Netherlands it's showing it every 15 minutes. That depends on how the data is being delivered by these countries themselves. And the Netherlands is also expecting to produce a lot more solar energy. And you see a curve you would expect. Slowly it's building up at one point to some kind of maximum. And then eventually it's going down again because the sun just goes away. So it's a very interesting resource to look at. And we can also connect with this platform with an API. Now I must warn you a little bit, because requesting the API key looks scary. This is the flowchart from their site. And effectively, this is just the only box you need to read, which says you just have to, once you've created an account, you have to send an email to a specific email address. And the first time I wanted to have access to this platform, I was like, well, let's just try it and see what happens. And I think there's some kind of automated process behind it, because a couple of days later, I just got my API key. There is some kind of manual review, but as far as I know, we as IT professionals can just request API access here. And it gives you a lot more options. Where with electricity map and so on, you had to pay for the forecast data. Here we just have it for free available. one downside, it is only available for European data. As we are at the European PowerShell Conference, I think for most of us that won't be a problem. But if you're working with companies who have an international reach, you might want to look into other data sources. And so it is also mentioned at the Cloud Carbon Footprint docs, where they say where you can find information about the different energy things. And there's also more specific platforms for different continents. So America also has their own platforms, which might work kind of the same like Ensue. I don't know for sure because the companies I work with mostly focus only on the European market. When working with them, or when working with the platform, I was pleasantly surprised by their API explanation. Their docs are actually quite well laid out and quite thorough. It does need a small learning curve to get into it, because there's not that much extra explanation around it what the things mean, but different enums, for example, PSR types is something we will look at later. You can click on it and there is an explanation. So these are codes which are used in the API to tell you what kind of data you're actually getting back. And it just shows the codes and the different explanations behind it. And there's many different explanations here. There's the reference document. There's also the different links here. And there's also here the link how to get a security token. That again brings you to this flowchart and a full extra explanation with a lot of screenshots on how to do this if you want to use it. And you might have already spotted it. There's also the Postman API documentation, which is awesome. Who here knows Postman? It's less people than I expected. So for the people who don't know it, Postman is a tool you can use to very easily test different APIs. You can very easily set up an API call in there with a graphical user interface, see what kind of responses you get back, and you can actually convert the things you set up directly into different kind of codes. PowerShell is supported. So if you set up all the different parameters right, you can just say convert this to PowerShell code, and it will show you the PowerShell code. So this is the web interface. In the web interface, here you can say also, I want to see it in PowerShell. And if we then look for example, generation forecasts days ahead, here it will show me how to do this in PowerShell. So I should be able to just copy this, with the exception that I need to enter my token in there and then run it in PowerShell. Here I've opened the thing in the Postman app itself. So here on the left, we again see the different ones. Oh, it does show it in screen. Sorry for the recording. Whoever now has seen this can see my auth token. I thought it wouldn't show it up here because it is also in here, but okay. Here we have the URL and I can say send and I will get the information back. There's things I can change, so I can click the URL and change it. And this way I can very easily test this API and test the different kinds of calls there are. Here it also shows all the explanations. So it shows here the URL I have to use. It says the document type. It explains, or it at least says document type, what kind of value I have. And I could go back here and I could probably look here for document type. And here it explains all the different document types there are. So we had A71, which is generation forecast. Oh, sorry. And it explains all the different parameters we need to send. It also shows you an example of the output being produced. So if you want to create some kind of tool around this, you can use this very easily to test it, see how it's supposed to be set up, so then you can build it. With that being said, I think it's time to start looking at some of the ideas I have to share with you. We're about halfway through it. Before we're going to share these ideas, are there any questions until now? Okay, so either I'm explaining it very well or everybody has already fallen asleep. I hope it's the first one. Are you still okay? Good? Okay. Are you looking forward to seeing a lot of code now? Great, because there's not many slides left. So, my first idea is I have automations in Azure and I need to run them sometimes. I have an automation, I need to run it somewhere during the day. But it doesn't matter exactly when it runs, just some kind of check I have to perform. And if it runs in the morning or in the afternoon, it's no problem. It could be re-indexing of my databases because I just see Rob join in. Yes, so, but it doesn't matter when I do it, right? If it's in the morning or in the afternoon, I can do it whenever I want. Yeah, indeed. So if I want to do a task like this, I want to do it at the moment when it's best for my environmental impact. So I want to schedule my automation automatically when there's the most green energy available in the region where I'm running it. So that's the idea I had. And that's what I built here. And now I'm going to share with you. And we're going to together run through the code and then run it. And hopefully it works. If not, I'm screwed. But we'll get to that eventually. So first there's a little function here. It's a function to calculate the distance. I want to thank whoever wrote this function because there's a lot of math involved. And although I did mechanical engineering, doing math in PowerShell is not my favorite hobby. So I'm very happy that somebody wrote this for me. And yeah, again, check out this site. There's many more of these interesting things on there. And I just borrowed the function and changed it slightly so it would just return the distance in kilometers. Because I'm European and not American and I like kilometers more than miles. Sorry. Then there's the geodata EIC region. A mouthful. What does that mean? So we had this view here earlier, right? And you can see, for example, that Sweden is divided in 4 different regions. These are regions for different energy suppliers or whatsoever. I don't know exactly the technical details behind it, but they're reporting on these different regions. So I think it's different grids or whatever. And there is interaction between the grids, but it's like a logical boundary of the grid. For people doing networking, I imagine it to be some kind of AS zones in Border Gateway Protocol. That's how I understood it myself. But probably there's not many networking people here anyways. So I want to know in which of these regions my data center is, if I'm running it in Azure. So I know which one I have to check to know best which energy I have to compare it against. Because if we, for example, look at this region by just the production type, if it's showing me anything, well, it was showing it before, but I'm not that used to this one at the moment. I've mostly used the other one before. But the different regions have different kinds of productions. So on the other side, there's also this overview. It's the same overview, and it shows these EIC codes. These EIC codes are the codes I need when querying the API. By giving this code, I say, give me the information from this specific region. Now, I would love there to be some kind of API available where I can just plug in my GPS coordinates and it shows me here. This is on OpenStreetMaps, so there might be a way. I haven't found it yet. But what I did found was an option to export the data. And you can also download it. And it shows here the codes. It shows if it's a polygon or a multi-polygon, and it shows a latitude and longitude. From what I've understood, this latitude and longitude is like the center point of this area. So if you all take the center points of the different areas, although the areas might be a bit weirdly shaped, in most cases, if you take other GPS coordinates and you calculate the one which is closest, you should be in that area. Because the center point is set up in a way that it's always the furthest away from any border of that area. So that's what I did, and I downloaded this information. It was in a CSV format. I converted it to JSON so I can easily put it in here. It's information which probably doesn't change too often. If it does, I would need to download it again and put it in here. I have checked if I can download this automatically. I found an API call being used, but there was some kind of session ID in there. So it worked for me like 2 days later still, but I didn't dare to just keep it to use it and then show up here, and it probably won't work then because the session just expired or whatever. It is something I want to contact them about, so if somebody from ENSU is watching this later, please get in contact. I think it's interesting to have this information available. And the other one is the PSR types. It's the table I showed before, where we have like the different codes and the meaning. I'm running this in an Azure Automation account, so I can use the get automation variable to get my token. So I don't share my token on screen like I did already. Let's hope Torsten will be able to blur that token out. And the next step is I'm going to connect to Azure. I'm using a managed identity to connect. You all know managed identities? I see some people, yeah, no need to explain. Good. And then there is this little commandlet called get AZ location, and it gives me all the different locations in Azure. Oh. Sorry, where did you go? I'm probably clicking somewhere wrong at the moment. Sorry? Oh, yeah. I was just looking. Sorry. It all looks different at the moment because I'm used to a different skin of VS Code. So if you look at a specific region, it actually also gives you a longitude and latitude for this region. Now, originally I was working on a script to get the GPS coordinates for specific data centers in different regions and so on. And there was data available, but Microsoft removed the availability of this data. It was somewhere in like their globe, in their overview for the different data centers, but it's now very visually appealing, but the coordinates don't match up anymore with what they're actually supposed to be, because too many data centers were too close together, so they moved them a little bit so it fits better in the picture. So yeah, this is the best I have. But by comparing this coordinate with the coordinate from the region, I can actually create a loop and go through each region and calculate the distance, or go to each of the ENSOI districts, calculate the distance, and then see which one is the closest. So I use a sort object to sort them by distance, and then I select the first one. This way I get the closest one. The next step is to create a start and stop interval. So I want to check in the future. So I want to look at the forecasting data. Some countries produce more forecasting data than others, but I've added a parameter which on default is on 24 hours ahead. And in the API, they have a format where they just have the year, the month, the date, the hour, and the minute in a decimal notation, not decimal, but in just a number notation. So I first take the current date, I set it to 0 minutes. I add 1 hour, so it's like the next hour, so I don't get any actual information, but I only get new information. If the best time to schedule it is somewhere in the next 45 minutes, I'm sorry, but then probably there will be a good time again soon. And the stop interval is 24 hours ahead. I also still have the hour, so I have the full 24 hours in the future. Then we build up the API calls. And I do this for the wind and solar forecast and for the total forecast. So I get the amount of energy they're expecting to produce by wind and by solar and the total amount. So if I would subtract those two, I would end up with the amount of fossil being done. Technically, there's also nuclear. At the moment, you can't see the nuclear by itself. It is a request I sent to them. I haven't got any information back. I probably have to send it again via a different channel, but I'm still looking where to send this best. This is also why I wanted to do this talk, to inspire you all, and if we all start asking these kinds of questions, they might look into this more. I hope all these things won't be on the recording, the bong bong all the time from the stage. Then I'm going to run through the responses I got back. And this is a very fancy loop. But what it's effectively doing is it's taking the value for the total amount and it's looking for all the different green ones being produced, because I said produce wind and solar, but there's wind onshore and wind offshore, which are two different ones, and there's solar, and technically there could be solar onshore and offshore. There are different commands for this. They are in this list, those PRS list. So I'm running through them and I'm checking which ones are actually presented, because some countries don't, for example, have offshore windmills. I don't think the Czech Republic, for example, has offshore windmills. So based on this, I'm making a table with the different types in it. I'm adding them together to get the total amount of green energy, the total amount of normal energy, or the total amount of energy, subtracting them to get the fossil energy, putting them all in a custom PS object, putting these objects in an array, so I can get a nice table. Before I continue talking, let's already start running the code so I can continue explaining it a little bit, and then we can see the run of it. So here I have the green PowerShell automation account. There's 2 large runbooks in there. At the moment they're very large. They're just a loop in a loop doing some weird stuff. But imagine them being very intensive workbooks, which need to do all kinds of stuff. And there's also Hello World, but you see that there's tags, and there's a tag for auto schedule. And I don't want this one to be scheduled, and these 2 I want to be scheduled somewhere in the next 24 hours on the best moment. I've got here my planner automation account. And once the runbooks load, Barbara probably is taking up all the resources from Azure with her talk about GitHub code spaces. We're going to start this one. I'm just going to leave this all on default values. And this is submitted. Now let's look further on the code. So the next thing what I'm doing is determining the best slot. I created this table of all the different points in time when they created the energy or in the forecast. And I take the one where the amount of fossil energy expected is the least. So it could be that it's somewhere during the night. For example, if you're in Sweden, during the night, there's almost no fossil energy being used at all because it's all hydroelectrics. In the Netherlands, it's somewhere during the day, the best moment, because we don't have hydroelectrics. We don't have any height to use. I mean, our highest mountain is still lower than the biggest building in this town, I think. So we have to use the solar and wind energy, which is more prevalent during the day. So in West Europe, if I would run this script, which I'm doing in a moment, it would probably give me somewhere around like 3-4 o'clock when they expect to have the most sun and most wind available. Because then the total amount of energy being used is a lot also, but because there's so much green energy, the total amount of fossil energy is not that much, because during the night we're mostly running on fossil energy and some wind energy. While in Sweden it will probably be somewhere during the night, because it's just no fossil energy being used. So it will detect this, then it will get the automation runbooks, and it will create a new schedule. And this schedule is set to the time when our slot was being determined. And then it's checking for every runbook which we retrieve from the automation account, if they have the specific tag set. And if so, then they're being scheduled. I think we had the filtering of the tag. Yeah, here we have the filtering for the tag already, the auto schedule. So here we're just running through the different runbooks and adding them to the schedule. Because if you create a schedule in a automation account, it just is a schedule, but you have to link a automation or a runbook to it for it to actually run. I create the automation schedule for only one time, so it will run once and then be done. And I create a name which has like the current date in it. So if I would create more schedules, they will all have a unique name. And I could actually sort on the name and just see the newest one first based on the date. and it will write some output. And it now says completed, so we can look at the output of this run. And it looks like something went wrong because it doesn't show the table here. So did we have any errors? We had some errors. This is always fun because it did work earlier. Luckily, we can just look at the earlier run. So this is the kind of table you would get. So it would show like the time, the total expected energy, the green energy, green energy, green energy, green expected, fossil expected. And then it would say, well, the best slot is at this time. Because something went wrong along the way, I don't know exactly what, and I'm not in the mood for live troubleshooting at the moment. Maybe if we have some time left, we can do live troubleshooting. It would create the schedule and link the automations. Because now I don't think the schedule is being created. No schedule is being created because it didn't have a time. And if it doesn't have a time, it can't create the schedule because it will take the earliest date available and then it says you're trying to create something in the past and it doesn't allow for that. But the other time it did work. Let's just quickly look at... I just can't help it. I do have to look at the error quickly. It says something about cannot bind parameter date to the target. Date cannot come. Oh, there's probably some kind of zero which it can't fix. Okay. Maybe if we have some time left, we can look at it into it. And this is why the other one's error. So that's my first idea. The second idea I have is to create an automation where I move a resource based on where there's the most green where the divide between green and fossil energy is the best. So I'm looking for a region where effectively there's the most green energy available. Because I'm not doing forecasting, I'm doing live data. And I want to see like where can I best put this. I could just look at where's the least fossil energy. But in this case I thought, well, let's look at like where is the percentage of green energy the most. It's a different way of looking at it. And we love some more demos. So that's this other script. I'm already going to run it. And I'm not going to run the whole script because running this will take a while because I'd have to set up a new resource and then move it over. But I will just run the first part so we can at least look at the table it should produce. So it has some parameters again at the start. It has the same function because I do need to calculate the distance again. I'm getting the token and now I'm also getting the from. So what I'm doing is I have a virtual machine. And this virtual machine, it's used as like an agent for my deployment pipelines. And periodically I want to check if this virtual machine is still in the best region or maybe it should be moved. Especially because if you're using an Azure DevOps agent, It already has a nice queue built in. So if I go to the agent pools and to green PowerShell, there's jobs here. When my agent is not available, for some reason, the jobs will still be queued here. Because it's a self-hosted system, it will be there indefinitely, unless I cancel it myself. So if my agent is down for a moment because it's being transferred to a different region, it will then pick up the things again and continue. The only thing I need to take care of is that it's not running a task at the moment. I didn't do that in this one, but I believe it should gracefully shut down, and with gracefully shut down, the agent should normally first finish off its task before it starts shutting down. But that's something in the code of the Azure DevOps agent. If you don't trust this, you could write something around this yourself to make sure that, for example, there's nothing in the queue, or just pause the things in the queue first, check nothing is running, and only then move it. And I'm storing in which region we currently are. So I'm storing, for example, last time I moved it to Sweden Central. And then I again load these regions. We talked about this before. Connect to Azure, get the locations just like before. And now I'm going through every Azure region, and I filtered the ones to be only the ones in Europe. Because I'm not in most customers I work with, they don't like it when I suddenly put their machine in America. So I filtered them to only be in Europe. But you could actually create a custom list if you want. You could say, these are the regions my customers signed off of, which are good for us. Take them. Maybe you could, for example, also base it on the amount of latency a specific region has. So there's different latencies between different regions. There's actually a PowerShell module for this to calculate the latency between the different regions. It's on the PowerShell Marketplace or PS Gallery. I made it by scraping some data from Learn docs, where they have a table explaining these different latencies, and it's updated once in a while. Once it's updated, the module will be updated and it has the most recent information in there. But you could, for example, say I have most of my resources in, say, Sweden Central, and I only want to have the regions which have a latency less than a specific amount, because you do want to have some kind of latency threshold there. But for a lot of types of resources, the latency probably doesn't matter at all. If it's, for example, a build agent for Azure DevOps, does the latency really matter that much? How much is there really going there and back? So we run through each of the regions, calculate the distance with all the different bidding zones in ENSUI to check which one is the closest. So we connect a EIC to every Azure region. I'm doing this now every run. You probably don't want to do this. This is a place where you probably want to do some kind of caching, and you only want to run this again when you notice things have changed, because this information will be the same every time. Then for every region, I call the current energy usage. So the current energy usage, it will give me a list of many different types of energy being produced. It's the one I showed you before from the Netherlands, for example. Let's do it in this one. So I can say actual generation per production type for the Netherlands for today. If I show it in full screen, we can actually scroll easier. And it shows here all kind of different types of energy which are being produced or can be produced and how much of it is produced. I've made a selection myself where I said that I think it's on the same order here, biomass, and then I think from geothermal all the way to other renew or all the way to the end are green energies and the rest is fossil ones. This is also something you can decide on. I added biomass to it. Technically or personally, I don't really think biomass is a sustainable fuel, but opinions change on this based on different researchers. So you can decide for yourself which ones you think. You can also say some ones are just going to ignore completely. And if it's renewable, I do it to the green energy, else I will add it to the fossil energy. And then I create a table with all the different ones and I calculate a percentage. What I've done is I said if there's no fossil energy at all, and there's also no green energy, then it's 0. Because then there's just no energy created at all. And when I was doing this before, at one point it was suggesting me to move to the region where there was no energy created at all at that point. Which is nice, but yeah. So then it's 0. But I said if there's no fossil energy at all and there's some amount of green energy, then just take the number for the amount of green energy. Because that means that we're only producing green energy. So it's probably a region I want to go to. And if I have one region where we're producing, for example, 5 megawatts of fossil energy and 20 megawatts of green energy, it's still a quite high percentage of green energy being produced of the total. And I just did a divide. I didn't even calculate the real percentage. So by this way, I should get, if there's a region only producing green energy, it should always be on top because it's just a very high number. And else it will give me the region where, there's more green energy than fossil energy. I output this table and then decide which one is the best. And let's see if this table did want to produce. Yes. So this is the kind of table we got. So Switzerland, at this point in time, when we're running it, is only producing green energy and no fossil energy at all. So at the moment, it's probably best to go to Switzerland. And I believe there's some kind of rivalry between Norway and Sweden always. So sorry for the Swedish people here, but Norway does win. With both of their regions, actually. But Sweden is still also quite high. But Sweden does create a bit of fossil energy at the moment. And yeah, the other region in Switzerland is also doing quite well. France is also doing quite well. I believe this is mostly due to like nuclear energy. I've added nuclear energy to the green one. If you add nuclear energy not to the green one or would not take it into account at all, I think France would be a lot less interesting. So that's also some things you can tweak yourself depending on the views of the customer you work with and what kind of things you want to support. So it would say at the moment, well, let's move to Switzerland North from Sweden Central. Because last time I was running this was somewhere last night. And last night Sweden was doing very well. Because there was no fossil energy and a lot of hydroelectrics being generated. Now this part I'm not going to demo, but I am going to talk about a little bit. There is the PowerShell commandlets to migrate resources from one region to another region. To use them, you first need to register the namespace Microsoft.migrate. And this will take a while. So you do need to introduce some kind of waiting loop to check if it's actually registered in your environment. I've put this into a setup clause because you only have to do this once. And after you've done it once, it's okay. Then I've said if move is true and we're not moving from the same from one region to the same region, because if I'm running this, say, every 4 hours, for example, and the next 4 hours Switzerland would still be on top, I don't want to do all this moving because I'm going to move it from one region to the same region. So only if there's different regions. I gave it a name and I used some GUID in the name to make sure it's always a unique name. And then there's this new AZ resource mover move collection. And this is a very long commandlet name. It's not the most funny one I ever seen. I still love the start. Is it AD sync cycle or so? You probably know it. Start sync, AD sync something. There's sync 3 times in it, I think. But this one is also very nice with mover and move after each other. And what we're going to do is we're going to create a collection in where we can put resources. And this collection will be moved from one region to another. So I have to create it in some kind of resource group. And then I say we're going to move from some region to another one. And here I created this resource itself in Sweden Central. It's only supported in a couple of regions. West Europe is actually not supported, but Sweden is. So win for Sweden. I thought there would be more Sweden people here actually cheering a bit for their country, but do I have an audience with all Norway people or so? Because I did hear some, at least. And it has a managed identity, a system assigned identity. This identity, I'm going to give some roles, so it's actually able to change these resources. Those are actually quite specific roles and quite high roles. You give them contributor access on the whole subscription. If you know specifically in which resource groups your machines are, you might be able to get away with only giving them access to the resource group. But you do need to make sure that if you're moving it to a different resource group, they also have their access on this resource group and it really exists. Because if it doesn't, it needs to create new things in the subscription and then it won't work anymore. After we're getting the resource we want to move. I'm moving some kind of specific virtual machine. And then we're running this command. Now, I'm not sure if it was my laptop, my installation of PowerShell or whatsoever, but I had to really nuke my complete install of the Azure PowerShell and reinstall the Azure, or reinstall and re-import the Azure PowerShell for this assembly to actually be loaded. So if you're doing this yourself and you get some error message about the assembly not being loaded, try this, it might help. We're setting up a target resource setting where we say it's going to move to this specific target. And then we're going to add the resource to the resource collection. Now, if I'm adding a virtual machine, I often have some dependencies because a virtual machine also has a disk, a network interface card, a virtual network, a network security group attached. So you can actually ask it to resolve which dependencies there are. or if all dependencies are being taken into the migration. If not, it will give you this specific error code. This is all also explained in the help docs. And then you can actually get all the dependencies. So it will detect which dependencies there are, and it will return them, and you can just loop through the dependencies and also add them to the resource. And I've added this in a while loop because I'm only getting the dependencies direct, so only one level down. So then again, if those dependencies have dependencies again, it will again loop and loop until it got all the different dependencies. You can technically go more levels down. It is not advised to do this by Microsoft. I haven't found out why exactly, but for now I was like, let's not challenge fate anymore and see if it's working. We get the mover resource, and what I did here is once you've added them, you have to prepare them, because resources need to be prepared in different ways, and the migrate commandlets, they know how to prepare them, but you have to prepare them all, and you also have to prepare them in a specific order. So I'm just going to loop through them, and if they said the preparement was successfully, I set them to ready, and else not. And if everyone is ready, I continue. Then you start a move. Then you need to commit them. And after the committing is done, you can remove them. And you can remove the collection. And then I set the automation value to the new location where we are. And if you do all these steps, you will move the resource. Now, both these runbooks I've created, I will share on the GitHub from PSConfEU. So you can just look at this code. And I will also share the slides. Oh, did we actually stop the presentation? So just a couple of last remarks. I was now demoing it with a virtual machine, which was not really high available. It's an Azure DevOps agent. If it's down for a moment, or it will continue working afterwards. If you have resources which need to be high available, there is something called a global load balancer in Azure. And you can actually put these resources behind the global load balancer, take one of them offline, move them to a different region, add them to the load balancer again, and then the other one, and move them also. And because it's a global load balancer, it will work for the resources no matter which region they are. Do keep in mind that also global load balancers can only be placed in certain regions. They can't be placed in every region. Only some regions have support for it. And the last thing, I've now demoed some things with making it more sustainable by looking at the energy and the amount of green energy being used. But this is a hard sell for a company. But these same mechanisms you can also use to instead check the cost API of Azure, for example, or another cloud provider. Or maybe check the energy price instead of if it's more green or whatever, depending on what kind of data center you're using. So you could use these scripts and say you want to move a resource to a different region. Also calculate if it's better for the price. And maybe build in some kind of logic where you say, well, for example, we were moving it to Switzerland now. And Switzerland might be more expensive. I don't know from the top of my head, but everything in Switzerland seems to be more expensive. So I guess their cloud platform also. But I can just go through the list and see if there's a different one, which is the same amount of money or even cheaper, and move it there. And then I can sell to my customer, I've made you a script which will put your resources in the cheapest region, which has the best energy, or in a cheaper region which has also the best energy or CO2 emissions. And we will periodically run this and move the resources, or we will schedule things to run in these regions. So that can help already sell this to your customers. Now do keep in mind, these kind of automations, they have some kind of overhead. It does take up some CPU cycles. The code I've written now is on purpose not really optimized to really show what's happening. You can optimize it a lot with caching and other ways. So use it, check what you can do with it. And just as a last, we've got like 3 minutes. And then there's 50 minutes of Q&A still. As a last thing, some future ideas. I would love to create a full-featured PowerShell module for ENSOE. So you can actually really use these things, because the APIs, they are quite nice, but they're not the most user-friendly APIs, and especially the output can sometimes be hard to handle a little bit. Because if you're asking, for example, from halfway today to halfway next day, you will get it in different data streams and then have to combine them again and so on. So having a PowerShell module which does this work for you and just presents it very easily for sysadmins to work with might help adoption. I haven't been able to build this yet. If you like this and would like to build this, or like to build this together, please contact me and maybe we can work together on this or get a group together to build this. On the other hand, Microsoft, I'm not sure if we have any Microsoft people here presently at the moment. They said they would be here, but I think they were scared away anyways. Because most of the time, if I'm giving a talk here, I'm also complaining about Microsoft. This time I saved it to the end. They used to publish sustainability fact sheets about all of their data centers, where they said, for example, the PoE, it's the efficiency of the data center. So if you put in 1 megawatt of power, how much power is actually being used to run the systems, how much is being wasted on other stuff, and so on. Until, I think, the beginning of this year, they published this for every data center, or almost every data center. They've stopped publishing these fact sheets. They now still publish fact sheets, but they're even more marketing jargon, and there's no real information in them anymore, except we're going to be carbon neutral, because they're building their roofs of wood. So I would love Microsoft to publish this kind of information again. It might be in a sustainability dashboard, but that's behind a higher license. And especially if you do want to do some research about it and actually not have a license, it's very hard to get by this information anyways. So if somebody from Microsoft is listening, please publish this data again. And not only the old reports, because I complained to them before and then they were like, we've now published it. And they published all the old reports, but not the new ones. Also, if we want to move to different regions and want to make it more sustainable and more energy efficiently, there's also underlying hardware. And different regions for cloud providers use different hardware. Some have newer revisions of hardware than others. With virtual machines, we can see this mostly by the virtual machine sizes, but especially with tools like Azure Automation Account or Azure Functions and so on, we only get information about it's a D-size equivalent underlying infrastructure. And based on this, we don't really know how efficient the hardware we're using actually is. So I want to keep poking Microsoft to release more of this data so we know better what kind of infrastructure is running our automations is running our code. So this way we can do a more informed decision on which region to use, because the regions with the most newest hardware might be better, although the energy there is actually might be less optimal. Because they're using so much less energy, it's still better. Also, not sure about most of your regions, but in the Netherlands we're struggling a lot with the grid just being overloaded, and many companies actually not being allowed on the grid at all. And there's a wait list for a company to be connected to the electricity grid at the moment. So instead of scheduling based on the amount of green energy available, I would like to schedule based on the load on the grid, which is actually a metric also available in ENSOE. So it's one of my next projects to see if this way I can also be more sustainable in a different way, where I help by running my automations and running my heavy tasks on moment when the grid is less strained. And with that being said, I think that's 90 minutes. 2 minutes over. Yeah, but we started like 1 minute over. And it's time for Q&A. So, are there any questions? Everybody is like, that is information overload. Has anybody here done anything with sustainability at all, or something with some green, making something a bit more greener? But you are interested in it, I assume, because you're here. Did you got some inspiration, maybe some ideas? Yeah.
Last topic you talked about, it was more about like redirecting your automation traffic from like big traffic, like the energy consumption, because like it's getting based on loads on the network, yeah, instead of being fossil powered. So but the issue is like we can't always do this because the customer wants a certain thing done at a certain time, right?
Yeah.
Like if everyone is doing that, can we have some form of a way? Because then there will be like a traffic kind of thing of like energy consumption.
Yeah, so the question is, say we're scheduling based on the load, for example, but it would also be, if we're doing it on the most amount of green energy, it would be the same problem. If everybody would do this, wouldn't it cause other problems, like some kind of traffic jam kind of idea, because suddenly everybody wants, yeah.
We need like shift it so we have
Yeah.
a better load over the day instead of more central loads at certain time.
Yeah. So IT is a significant impact of the energy grid, but there's a lot of stuff using energy grid. So and even in these data centers, there's still a lot going on. So at the moment, I think if we all would take all our automations and run them at the same time, it will be a bit of a bleep, but not that much. And also, it would self-regulate itself already, because these data centers only have limited capacity. So it will just be queued, and you will have to wait longer before your automation has been completed, because eventually you just reach the maximum amount of the data center's capacity, and then you have to wait longer for it to finish loading. So I think it would kind of self-regulate already. If we continue with this for a lot, then eventually maybe we want to do some kind of orchestration on this, but that's so far in the future still, I think. There was a question there, or? Okay, I thought I saw a hand being raised. You also said something at the start which I wanted to reply on, but I forgot what you said at the start. Don't know anymore. Any other questions or remarks or just fun things to share? Yes? So I'm not sure if it's still available, but GCP, Google, used to have a region picker tool available where you could actually just say, I want to have the greenest region available. It was just a tool where you could fill in, like, these are my requirements, and it would spit out the best region available. I would still love to make a tool like this for Azure, but there's a lot of extra things, and making it really useful can be hard, especially if you also look at like dependencies and so on, because most of the time if you're deploying a resource, you're not deploying a resource by itself. It's connected with other things. And if you deploy everything in a different region, you might run into problems. So there needs to be some kind of logic in there. With that being said, as far as I know, it's public knowledge. If not, I'm very sorry. Microsoft is already experimenting with managed availability zones, where you can just say, I've got a resource and it needs to be in an availability zone, but I don't care which availability zone. Just pick the best availability zone for me. I think this is a first step towards maybe eventually also being able to say, I need it to be in a region. It doesn't matter to me which region, just pick the best region for me. And probably when first deploying this, they will mostly look at cost and resiliency and some of the other pillars in the CAF. But eventually, if these systems are in place, it wouldn't be that much extra work to also add sustainability KPIs to this. And maybe eventually you'll be able to tailor a little bit what you can do. So I think the groundwork for this is being laid, especially with more and more regions getting a bit full and getting some capacity constraints for multiple different cloud vendors. I think more and more they will move to a situation where they will recommend you regions. If you now create something in the portal and you select West Europe as your region, it will already give you a message like, hey, did you know that there's also other regions close by which you can use and they might be better? I think this messaging will only become stronger and stronger, and eventually it will just auto fill it in for you or give you whole explanations why. So yeah, I do think in the future it will move more and more towards this, and we having to think less about the regions and more that we should think about the actual reasons and the actual constraints we have, and think more about our non-functional requirements, like things like latency, performance, resiliency, and so on, and entering this into a system, and the system will decide for us which region would be best, instead of we're entering a region. I hope this answers your question. Is there any more questions? Yes?
You mentioned earlier when we were limiting CPU cycles, and then you finished with implement caching.
Yeah, trying to get it back to the right slide, but yeah. So implement caching. It could be very simple things. Recently, for example, I've built the module for the Azure network latency. And in this module, I stored a table with all the different latencies available. And there's also the online table. So online, I've got a table, and every now and then I check in the Azure documentation if their table has changed. And if so, I'll update my table, because their table is not something a program can interact with. It's just a markdown in some kind of document, and I've got it in like a JSON format. So I could, every time that I'm running this module and somebody is doing a request, I could just go to my table online and request it. But this table is not changed that often. So I just have a version embedded inside the module. When you build it, when it's built, it takes the newest version of the table and embeds it. And there's a switch in the module, which says switch online. And if you use the online switch, it will go to the online table. But by default, it will take the embedded table. And this is a form of caching, where it's not always going to this place, because most of the time it won't be changed. And if there's a new update available, it will build the module again and upload the newest version of the module. And if you update your module, you've got the newest version again. But if for some reason you don't want to update your module, you can use the online switch to get the newest information also. And you could even build in an option where the first time you run this module, it will store it locally on the device for you. And then you can actually also update your local storage of it. By using the online switch, you could actually make a new offline storage on your device. Those are options. But that would depend on what kind of infrastructure you're using. If you're using a stateless machine to run your automations, this won't work, because every time you will have to retrieve it again. But if you have a stateful machine where you run your automations on, that would work. Is that clear? Okay. I think I forgot to repeat the question, but I think by the answer the question is also clear. Any more questions, or is it time for lunch? Then thank you very much for listening. And check on the social, check out my blog, contact with me, and I hope somebody will contact me if they want to help a bit more with these things. And don't forget, in the app, if you open the session also, after you've been to it, you can actually rate it and leave feedback. So I would love for you all to do this, because only this way as speakers we can also grow. Thank you very much and enjoy your lunch.